When the forest tent caterpillar moth reaches maturity, it emerges without a mouth. It can't eat, is an inefficient flyer, and if it manages to survive predation and weather, it has only days to find a partner and mate before dying of starvation, exhaustion, or old age. On the other hand, in its larval stage, the baby caterpillar spends weeks with hundreds of its siblings who molt, rest, and warm on communal silk mats and forage together, mapping trails to viable food sources because caterpillars are, of course, always hungry and almost always eating. Survival is predicated on cooperation, communication, and a certain amount of instinctual unpredictability. A playful surplus that even among insects in infancy constitutes variation, spontaneity, improvisation, and what some might even call creativity. In what animals teach us about politics, and this is the only kind of intellectual quote of this whole thing, philosopher Brian Massumi writes, quote, "Play instinctively belongs to the aesthetic dimension," and he posits, "when we humans say this is play, we are assuming our animality." So what you're seeing is a kind of making of video from my bigger project on caterpillars, of which some of these things are part of it. So I'm going to show you stuff that you can't see in the gallery. Some of this is sort of raw in not the form where it would be exhibited, but I'll go over that. So before I continue, I'd just like to, so this is about my caterpillar art. Am I standing too far from the mic? Sorry. I'd just like to thank apexart for inviting me. This is a great opportunity. Elizabeth, Ryan, and Chelsea have been really helpful, so thank you. And also there's some people here who I also would like to thank. So Emily Falvey is the curator of this exhibition. She did the open call, and I had never met Emily before she did, and I don't know if she knew any of the artists. She wrote this essay. She happens to be in Montreal, but she walked by a show of mine and then applied for this, and I guess she probably thought it was a shot in the dark and told me after I got this email one day and said, "Will you put your work?" And I was like, "Of course, of course." So the other people are my collaborator, Christopher Plenzik, who worked on the drawings with me, and my previous collaborator, Jessica Effier, and both of them worked in the entomology lab at Concordia University. So they're my collaborators and bug suppliers, and of course all the hundreds and thousands of caterpillars who actually helped me make this work. And my university also, so who sponsored me to come here. So this is very informal, but I did separate this into like a 5-part talk. So I'll talk about history, which includes a little bit of not just my history, but because I do history, inspiration behind the work that I'm doing. I'll talk about Malacosoma distria and en masse. These are the two major caterpillar projects that I've done. Malacosoma distria, the tiny little little video in the front. The first one you see is from Malacosoma distria, and the drawings are from a project called En Masse. So I'll talk about those and show you footage and things that aren't here. And then we're going to do a participatory demonstration so we can all do kind of caterpillar stuff. So start with some history. So my background is actually animation. That's what I studied in university a very long time ago. But now I work digitally, and so I teach and I work in digital media. Like 3D animation is where I kind of got started in my professional career. But as an academic, someone who's been in grad school forever, I'm really interested in the history of moving images and 19th century, and it's sort of 3 threads that come together in both my research and writing and also in my art production, and that's optical media technology, so like gadgets, but pre-digital gadgets. Scientific spectacle, which is sort of the kind of entertaining side of scientific imagery, and then as an animator, always really interested in movement, and particularly animal movement, so animal locomotion. So here are some sort of key figures. When I look at them, they all are dudes, but there are other people who inspire me. Also, because I do 19th century media history, I'm also interested always in the political aspects. So ideas about representation, visuality, voyeurism and surveillance, and sort of these power knowledge in terms of how science is used and how alternative truths are also used to convince people of power relationships. And I think animals interest me because I think the way we treat animals is very similar to the way we tend to treat people who have less power. So this is actually my PhD thesis, and this is something that was promoted by a woman from the 1840s. So before public museums of science, she was showing optical media, new media so for that time, so like the electric telegraph, the railway, the chromatope, and the microscope and the telescope. So that's sort of what I'm doing in my research. So this interest goes back a really long time. This is my graduating film, so this you can see how old I did. I finished university when I was 5. Yilin was there with me, so we were both very young. And I was interested already back then in scientific imagery, and this idea for my final year film, which I never finished, was a documentary about the HIV virus. And I had this idea that if we could look at it understand it better, what was happening at the molecular level, then it would be a way of talking about it with stripping away all of the kind of ridiculous stigma around that. And of course, it was the early 90s, so there was lots of strange, moralizing discourse around AIDS. And you'll see these sorts of things come back. Also very interested in technology. So that's done with a computerized camera, which is the only camera that I learned, and colored photocopies. After I finished university, I didn't have any skills, so I went back to school and learned 3D animation. And I ended up in Japan working for a game design company. But out of that, I found this amazing story about a volcano that erupted in Japan. And so I ended up doing my very first film for the National Film Board of Canada about this volcanic eruption, and specifically a postmaster who lived in the area named Mimatsu, who invented this Mimatsu diagram. And basically, because there were no scientists, it was during the war that this happened, he became a kind of citizen scientist. And then eventually I went back to school, so I have been in grad school for a long time. And I decided to take my 3D, I was asked by the NFB, the last thing I was asked to do was to do a 3D stereoscopic film. And my topic was origami, because I thought this was a really interesting metaphor for doing 3D, this idea of having this flat screen-based going from the screen to off the screen, so from paper to 3 dimensions. And because I wanted to exhibit it not on a screen with glasses, I ended up going to, this is what started me on optical media history, I ended up redoing a Wheatstone stereoscope. So this is from a device from 1838, and you look through mirrors, and that filters the left and right images and creates a 3D image. So I'm just going to try and zip it through this. And then the other thing that I did, I just realized I didn't start my timer, was I took a course on bioart. And I became really interested in the idea of working with living things, because I've been working with computers and things that weren't ever moving. I was an animator. I never worked with actors. Well, I worked with actors for voice actors, but I wanted to do something a little bit different. So these are baby-shaped zucchinis that I grew in a greenhouse. And essentially I did 3D. I used my 3D skills. 3D printing was at the beginning, was just in its infancy, so I did 3D prints of babies, vacuum formed molds, and then I grew vegetables. in them. So this was my entrance into working with things that were alive. And it's a lot about, sort of about the assisted reproduction and surveillance of the body. And so these were grown and then I pickled them, so they were pickled vegetable babies. And I did documentation because I also did surveillance on them with time-lapse and web cameras. So we'll just watch this for a few minutes. Okay, so I won't show you the whole video, it's about 5 minutes. So, now we're going to go straight to the caterpillar. So that's sort of the background of how I get to caterpillars. I don't know if that makes any sense at all. But you'll see that the microscopy kind of is there in 1991, and it then comes back when I start doing these weird things with vegetables. And the other thing, this is from Mariah Short's poster, her handbill. So that's my thesis. And one of the things that she would have shown was these solar microscopes. And a solar microscope was invented in the late 18th century, and it was essentially a projection of slides. And in this one, I'll just read it. It says, a single drop of water is transformed into a little world teeming with animalcules, or rather animals of wonderful size and construction, wheeling and darting with amazing agility and following the general law of nature of devouring and being devoured. Cheese mites, larger than lobsters, are seen tugging and fighting, and the eye of a fly is magnified into an expanse of 12 feet. So already in the late 18th, early 19th century, people are looking at microscopic imagery as entertainment. And it's a solar microscope because a microscopic image requires a lot of light. And so this would have been stuck into a hole, through a hole in a wall. And there's a mirror, and it would capture the sunlight, and the sunlight would be used as the illumination for the projection. And so I thought this looked a lot like a film called Mothlight. So Mothlight, I don't know if anybody knows this film. It's a really famous experimental film by a filmmaker named Brakhage. Mostly people think of Stan Brakhage, but he was actually also working with Jane Brakhage, who was his partner at the time. And they sandwiched insect parts in between film strips in a technique called direct animation, which is also often done with drawing and scratching directly onto animated film. And so I realized when you stop a frame of Mothlight, it's basically like a solar microscope. It's a projection of a magnified image. And so this is Mothlight. And I also thought of mothlight because my own microscopic animation is really jittery. It's kind of really frantic and all over the place. It's also backlit because that was the kind of microscope I was using. And so this is sort of how I ended up working with moths. I wanted to remake mothlight with a new microscope. But I was also really squeamish about like having to find dead insects. So because I'm interested in history, I went back to the kind of things that other people who animated with insects did. And so this is the very, Ladislav Starovich, this isn't his first film, it's probably his most famous one. It's called The Cameraman's Revenge, and it's about this grasshopper cameraman who takes revenge on a beetle by filming the beetle having an affair with a dragonfly. But he does this by hooking up insects. So these insects are the very first, insect bodies are the very first puppets. And what I find really interesting is that Starovich was not a filmmaker when he started doing this. He was actually a museum director. He was the director of the Lithuanian Museum of Natural History. So he's working with scientific specimens. So I thought he was quite interesting, very anthropomorphic stories. And then this is another film by Paul Bush, who's another experimental filmmaker, who did a film called Darwin Sleeps with the with the Lucerne Natural History Museum. The Walter Linsenmeyer collection filmed thousands and thousands of insects. And this is the end of it. And so not anthropomorphic at all. Instead, what he does, you'll see at the end, the camera or the viewer or maybe the filmmaker sort of become an insect. So I was really interested in this, not so much. So yes, the caterpillars that I work with become artists, but I was also interested in this idea of the filmmaker or the artist becoming an insect. And you'll see here that Paul Bush is also very squeamish about killing the insects in his film, and he's very happy to give that responsibility to someone else. So this is my first talk. My first project is Malacus omidistria. It's reanimating moths in science, so I want to do my 1-week short film with remaking mothlight by just getting somebody to give me moth wings, except that's like 10 years later, practically, I'm still doing this stuff. These are my body suppliers. This was a lab in 2011. My main informant is Jessica F.A., who was a PhD student and then went on to run this lab. And we went together and we collected caterpillar eggs for her work. So these are the caterpillars that I work with. They're called the forest tent caterpillar, Malacus omidistria. They are indigenous. They are across North America. They are the only tent caterpillar that does not make a tent. So tent caterpillars usually make these big, silky, ugly masses in trees in the forest, and they will go out and they'll eat, and then they'll go back to the tents. But these ones are nomadic. So instead of making tents that they return to, they make these little silk mats, and then they all hang out on the silk mats when it gets too cold or too rainy, and they use the mats for thermoregulation. So they warm up their bodies so that they can digest food and have enough energy to go out and eat again. They're very prone to outbreaks. They're swarming caterpillars, so there are years or places where you'll go out and they'll be everywhere, and a lot of people are really disgusted by them. But because they're prone to outbreaks, and those outbreaks seem to be a bit sporadic, they may be an indicator species to show like climate change or some kind of breakdown in an ecosystem in a specific area. And then if these outbreaks happen too often, they defoliate trees, so they eat leaves because they're hungry, and if it happens too many years in a row, they can cause a great deal of damage to trees. So their life cycle is, they're only really active for a couple of months. So they're hard to work, they're not hard to work with, but you can only work with them for a specific time. They're active as caterpillars for about 3 to 5 weeks from May to June. They go through 4 to 5 instars, meaning they shed their skin 4 to 5 times. And they shed their skin because they're getting bigger and bigger and bigger, so they have to change, they let go of their skin so that they can eat more. It's like, you know, changing your clothes because you're getting fatter. And once they get fat enough, they can spin their cocoons because they've got enough energy to turn into moths. And then the moths come out for a few days, they mate and they die. So they're terrible flyers, they don't eat, and if they're lucky, they will mate. Lucky, I don't know. And then they lay these eggs, and these eggs, if they survive, they have to last an entire winter. So the reason that I was able to do this is because Jessica was doing a study on moth wings. So quite often this lab does not actually raise caterpillars all the way to moths, but she was really interested in the wings. So she raised over 3,000 caterpillars all the way to moth stage so that she could study the color difference in the wings. And this turned into a big show, well, not a big show, but it turned into a major work from like 1 week of just me under a microscope by myself to this full year of, well, not full year because it was really the time when they were alive, of her calling me and me running over and filming the caterpillars and the moths as they're going through different stages of their life. And this was a show in 2013. And part of that show was, so that big projection is over there on the wall, really small, but normally it's been shown like about 16 feet wide. I only like it really big or really small. And then it was accompanied by a specimen table with a video embedded in a table with petri dishes of specimens on top of it so that people could get a sense of the scale of these things. So this is actually video that was under the table, and I've never shown it in this format. And this particular video, I wanted to highlight the work that the entomologists were doing. So this video was a very self-reflexive video, and a lot of my work is about thinking about process and how things work. And so it's about the manipulation by the scientists and the care and the skill that goes into studying these things. So that's Jessica, obviously. And this is like, for example, that's bleaching, egg bleaching. And this is probably also the only place where my kind of Stan Brakhage filmmaking sort of comes through. One of the things that I really learned from Jessica was I learned a lot about ethics through the scientists. So I'm not sure about in the US, but in Canada there are no ethical guidelines for insects, for invertebrates. You can do anything, otherwise, you know, you wouldn't be able to eat lobster. Like, you can kind of do anything to an invertebrate, except for octopus. Octopi and squid, they have, I think they're intelligent, so you have, if you want to do any research with them, you're supposed to do something. But what was interesting was the people who work in the entomology lab, they are incredibly careful with their insects. If there was a researcher who wasn't feeding or cleaning their insects, they would be shamed. The insects would just die if they weren't being taken care of. And you could preserve them for experiments by just drowning them in alcohol, but what they tended to do is they euthanize them by freezing them. And so they go to sleep. And, you know, that seems kind of, maybe that seems kind of weird, but I thought it was really fascinating that Jessica and the other people who I worked with, they would pay a lot of attention to when the caterpillars or the moths seemed to be suffering. Like, they would watch out for disease, but they would also watch out to see if they weren't getting out of their skin, they would euthanize them quickly. And their survival rate was like, I can't remember. It was crazy. Very, very high survival rate of insects in the lab because they don't have to worry about weather, they don't have to worry about starvation, they don't have to worry about predation, and they really try to minimize disease, infection, parasites if they can. So there's also quite a bit of stop motion animation in here. This is dissection. And I find it incredible that people can do dissection of an insect. And also has all of these stop motion animations with the dead moths because I also have this kind of fantasy that they would be trying to escape. And all of those moths have only one wing because she took the other ones for her experiment. So 2013, I had my big exhibition. Jessica graduated, she became a doctor, and I thought this was totally over, except this other person in the lab showed up. His name is Chris Plenzek, and he did this, his research was called Should I Stay or Should I Go? And he was studying foraging and social behavior of insects. And he wanted to do, he told Jessica, I really want to make living paintings with caterpillars. Because these caterpillars, the way they talk to each other is they lay down pheromones and they follow each other to food sources, which was sort of Chris's research, except that these pheromones are isolated in liquid form and maybe synthesized, and they had some in the lab, and if you paint with paper, you could get these caterpillars to follow patterns. And they would reinforce the path because as they're walking, they're laying down more pheromones, so they'll just make these patterns. So this is from my work with Jessica, so I knew exactly what he wanted to do. And Jessica said, call Alison, she'll do something with you. And I wasn't planning to, but I could not resist. So I said, okay, if we're gonna work together, I'm gonna do things differently. I don't wanna think about these insects as just objects. Let's think about them not as material and living paintings, let's think about them as performers, and we're gonna choreograph them. We're also going to apply for a show, so we did this show in this corridor of our university, which has a metro station right underneath it, and so it gets a lot of traffic, and it's, I think, about 32 feet long of 1-foot glass vitrines. So that, and we proposed to do things like we sat inside it and we raised caterpillars on site. And I set the bar so high that I did not think we would be accepted, the show would be accepted, but we were. So, so then we had to make it. So this is Chris. Caterpillars are only alive for 3 weeks out of the year, so the year before the show, he's doing field work during the day. We had to do all of this at night. So we got the animation the animation department to give us a studio. And we did all our filming with animation equipment, whereas with Jessica it was totally kind of ad hoc, on the fly. She'd call me up, say, they're about to hatch, come with your camera. And I just set up anywhere. This time we had proper things. So this is the show. And this is where what Emily would have seen. And it starts off with, it's a bit dark. We have lab coats made out of silk, cocoon silk, and I'll show you how we made that. We had caterpillars on site that we raised, and they were research caterpillars. We kept them on a controlled diet so that they could be used in a food study. And people watched them all the way from eggs. It was great. Like the day after the opening, they started to hatch. So people saw them grow from really tiny to quite large until we actually euthanized them from the study. So I had to kill them in this case, but it was good for me because I learned how to be more careful and not so cavalier. And here's the caterpillar choreography, and I'm going to show you this, we do this in the demonstration. These are screens that were inspired by the mats that they wore them on, and so they're made of silk. And this is the work that we had done in the animation studio the year before. And what was great about the show is because it was in a Concordia building, people would walk by this every day. And we hung out there, so we would see the same people come by day after day to check on the caterpillars and watch them grow. And some people got really grossed out. First they were like really cute, but then as they got larger, because there were hundreds of them, people started getting really disgusted and upset. And but we tried to stay there so that we could answer questions, and because we were taking care of them. So this is the choreography that was projected onto the screens. So normally I never show this like this either, but I will show you the screens. So how am I doing for time here?
You're doing okay.
So I think, does anybody have questions? No? I'll pass around the screen material and then.
I have a question.
Yes.
So you place the pheromones to create specific patterns here.
Yeah.
And they follow those.
And they
patterns.
follow those.
How do you decide? I mean, it looks like a lot of them are going in a similar direction a lot of the time.
Not all the time.
No.
They will go in any direction. So they will go in either direction. Oh, that's called frass. That's their poop. And sometimes they decide to go off, which is what is so interesting. So I found they will go in either direction because the pheromones are not directional. So sometimes they would go in the opposite direction, and then sometimes the caterpillars would make new paths, which is what is really interesting. That's how they actually, otherwise they just walk in circles for hours, and they will do that in nature, they'll get into a loop. So this wasn't exactly something that we invented, it's sort of something they invented. We were there and we just decide on random patterns to put them in, and then they follow us. And often we couldn't tell. So all of this is shot with time lapse because they're slow and it's often kind of boring to watch them. We weren't always sure until we played back, sped up, whether or not they were following patterns. So some of them, I think like this, when they're going through here, I think that's something they did. I don't think that's it. Yeah, I think so. And it's also size dependent. So we also found that as they got older, just before they were about to getting ready to spin cocoons, they stopped following each other. They would try and avoid each other, probably because they want to eat their own food, or they just get very independent. So that's where the drawings came. Because the drawings, they're not following patterns. They're just walking wherever they want. So we thought, oh, well, this is an opportunity to trace their patterns. So we drop them in charcoal and let them go. And then later on we started to try and be a little less random with it.
I was going to ask next if there were pheromones involved in this other project.
No.
This is what
any pheromones in there, they're actually putting down themselves, but they're ignoring each other's pheromones at this point. Because they're always laying down pheromones and they're always laying down silk when they walk. Constantly. Always. So, yeah. So I have some silk. This is fused silk to pass around. I'll pass it around. And here in the back, it's etched with a caterpillar drawing, because all the work, the drawings and everything are done a year before the show. And then all of these lines are actually silk. So they're paths and then they're the silk. And
could you make it full screen?
Oh, sorry. It might disappear because it's on a loop. So this stuff is all silk. You might be able to see it earlier on too. Here. On this, you can see all the silk on the glass. So we collected it, but it was like tiny little bit, even though there's hundreds of them, because they're not like And usually the silk is full of frost. So, shall we?
I just one more question.
Yeah,
Sorry,
no,
if anybody
please.
else has questions, please. But so in the process of collecting silk, it becomes that thing in the back.
So that thing in the back is not our caterpillars.
Right. I'm just
That is
curious,
commercial.
about the process of how those things are made.
Yeah, absolutely. So those are commercial silkworms. They're raised. Silkworms have been, the silkworms of most silk that we wear, they're totally domesticated. I think they might even be older than cows, like 5,000 years of breeding silkworms. And they create these very fat cocoons. And the silk that we wear, they put them into a warm water bath, and there's some legend about a silk cocoon dropping in some lady's cup of tea. And when they're put in warm water, you can pull a thread, and they unravel. So silkworms are unraveled. These particular ones are not unraveled. These are washed in some kind of degumming agent, some kind of washing agent, which gets rid of the gum that holds the cocoon together, or the kind of glue. And then they're washed, and there's about 4 here. And then they're stretched, and then they're put onto a little board with 4 nails, and they're pulled over it. And these are called silk hankies. And this is what I use to make the cocoon, what I use to make the fabric. So these things we'll show you, this is part of the demo, but these could be used for somebody doing felting or spinning. That's why you can buy them commercially, and I use them for making the fabric. So, cool. Yeah.
Shall we do a demo?
Shall we do the demo? Yeah. Let's do the demo. So, I have, this is sort of like a backwards, it's like a cooking show, because we're going to skip the tedious waiting wet part. So this is the end product, and this is done with gelatin. So as you can see, what I've done is I will stir it. So this is dried, infused, and I'm going to pass it around, and then everybody can do this. So I'll just start it. Hopefully it works. I did it last week in my house. And what it is that silk, and it's fused. And in this case, because I'm really interested now in doing stuff that's biodegradable, the silk that was done in my show was using an acrylic-based medium. This is gelatin. This is done with just knots, like, for making Jell-O, except no sugar or flavor in it. And because it's an animal protein, it does a beautiful job of fusing silk. So that's all it is. So I've passed these around, and maybe people can try fusing them. And then I'll show you how these things are done. So I can I got a few different ones. So you can share. Do you have any other questions?
So it sounds like you learned a lot about like scientific treatment of bugs and stuff like this, but so there was no hesitation for like the departments when you were using, I'll say, like leftover moth bodies and single moth wings. Once they pluck them and they can do whatever you want with the bodies.
I was allowed to use wild caterpillars in school, and no one asked about it, but I think the belief was that we were just plastic. And we were very careful. Yeah, we did. We were very careful with them, but we didn't really have to be.
This is like traditional silk, not silkworm. This is silkworm silk.
This is silkworm silk.
Yes. Does anyone use commercially the silk of the caterpillars you were working with?
No. So as far as I know, there is no such thing as truly wild silk. So there are things called wild silk, but they're more like free-range silkworms. So they might be raised in a forest, but the forest is heavily guarded and protected usually by children. Yeah, I think it's probably pretty problematic, right? It's pretty strong.
This would be sold for people who wanted to spin themselves? Is that
Yeah,
what you're
this would be probably used for people who want to spin or use it in felting projects. And they might be faulty caterpillar, like ones that they don't bother to unravel. But it's also used for quilting, so I'll show you how that's done.
Wait, what is this caterpillars eat?
They eat leaves.
So how much leaves do you have?
We didn't raise them on leaves, we raised them on sterile artificial diet. But if you do raise them on leaves, you have to get a lot of them because they
Any
eat
leaves?
No,
Oh.
they're preferential eaters. So they generally in Quebec, around Montreal. So depending on where you are, they will eat different types of leaves. So in Quebec, they love sugar maple and trembling aspen. Actually, they love trembling aspen. That's like their food of choice. But they can survive on sugar maple. But then in an outbreak, during outbreak, they'll eat anything. So we found them in another university, it was outbreaking while we were doing this, and we found them sort of eating rose bushes on the other university campus and apple trees, and I don't think they really liked it, but you know, they're desperate and really hungry, so yeah, you do find them on different things.
But you fed them, you didn't feed them leaves, you fed them.
We fed them artificial diet because they were used in a food study as a control group on a study on toxicity. So
So what was the artificial diet?
the artificial diet is some kind of powdered mix you get from science suppliers, and then you put them, you suspend it in agar, you know, like agar, which I think is super cool. The other thing that I use so I have used vegetable gelatin, so agar, and konjaku to try and infuse it, but I find it's soft, like the fabric medium. It's very nice, except it's very hard to pull apart. So I figure for this demonstration, it's nicer to go with the gelatin. So do you want to see how this is stretched? I need 4 people to come up here. Grab a corner. Can I get 3 other people? And everybody, I brought enough that everybody can do this. Anybody else like to come and grab the last corner? Yeah. Oh, you can all come on up. I brought enough for everyone. So you're gonna walk backwards. Just pull, just be careful, maybe come to the center. And what we did is we stretched this. And this is the way quilts are made. And so you can just drop it on the floor and we'll do the next group. So just drop it. So what we did is we did 100 of these for a 5-foot screen, and we put them between mesh. And then to fuse them, we put, so you can hardly see it, we need to big it up. To fuse them, you put hot soapy water on it, so it opens up the fibers, and then we fuse them with a medium, so it could be gelatin, it could be plastic. So we can do another set. Because it feels neat, huh? Yeah. Let's pull it up. And after this, what we'll have is we'll have a mask, but I'd be able to use it for spinning or something. Or spinning or felting or anybody. So just be careful not to step on the silk on the floor. You can't see.
Should we move it?
No, that's okay. We'll
Is there more than one?
just grab it. Yes, there's always more than one. We usually spin 4 at a time. It doesn't matter. Oh, so you want to grab a corner. Oh, just leave that one.
Leave that one.
It's okay. It's cool, huh?
That's so crazy.
So if you go online, you can see usually Chinese ladies doing this, and they use it for quilt lining because it's super warm. Silk is really warm, which is why the caterpillars use it. They use it to keep warm while they're, does anybody else want to try this? You can kind of do it more than once. It's very soft. So you want to grab the corners. And you might all walk home with a bit of caterpillar silk on your feet. So you need one more. So we would do this. We do it usually about 4 at a time, and we'd have about 100 cookies before we make the cake.
And the stuff that you showed earlier that you pulled apart, what's can you repeat the difference between like what that would be used for? That's for the screen making itself.
This is all for the screen. This is all this stuff. Wait. Oh, that's the end product of this.
Got it.
So you would put this on. There's still more. I brought lots. If anybody wants to do this, would everybody have a shot? Yeah. Okay. So yeah. So this would be done built up in layers. I'm going to pull this up onto nylon, and then the nylon is wet and then soaked with fabric medium. We hang it up to dry. So that's the point you get to not do, which is the soaking it, putting it in medium, and hanging it. That's why it's like a cooking demonstration. Like that stuff is kind of messy and a bit boring because you have to wait overnight for it to dry. And then the magic is when you pull it apart and you've got this beautiful screen which you can use. So these ones I think would be really great for origami because I think it folds really, it's nice and crisp. So it makes really nice paper. And you can draw on it, and you can fold it, you can do other things. But if you use a softer medium, like a fabric textile medium, or as I use like vegetable-based gelatin, it'll be soft. Yes?
If I were to like search for those little like
These are called silk hankies. So like handkerchief. And you can buy them at any kind of felting or knitting supplier. You can find them online. You can find them on Etsy. They're already pre-dyed. You can also dye these things really nicely before you send them or before you do something with them. I have the price on my package. It's silk, so it's not cheap. But it's also not crazy. It's cheaper than buying silk clothes ready-made. Yeah.
I came a little late, so I'm going to miss it, but could you talk a little more about the pieces you have here?
Sure. So this was after the oh look, there's silk on top. That's so cool. That's awesome. So I like that. So the drawings are done. So once the caterpillars stop being following orders altogether, like they're never really good at following orders, which is what makes them really interesting. They'll just walk in. When they get to a certain size, they will just go anywhere. And we knew at a certain size, we weren't so worried about harming them because they're very resilient when they get to that size. So we made this thing called caterpillar cartography. And so it's just basically our giant caterpillars who had previously been our performers. We thought, well, if they can perform, if they can make fabric, then they can draw. So we just used little charcoal, little stick charcoal, it's very soft charcoal, sanded it down, put it in, sometimes we drop them in the charcoal, sometimes we just put piles for them and just let them go on a piece of paper. And so those are caterpillar cartography, so those are drawings. The furthest left was actually done a year later during our exhibition, because during our exhibition we did 3 workshops. We did a workshop where we made screens. So they were just free workshops with the public. We did a workshop where we got pheromones and we call it caterpillar tea party, and it was for children. So we got our caterpillars and let the kids play with them, and we did drawings. The children did drawings, and then we painted on top of them, and then the caterpillars wandered around their drawings. And then when the caterpillars were big, we actually dropped them in charcoal and made drawings with people who wanted to sign up. And so that came out of the drawings. And that was really interesting because people started saying, oh, what happens if we put the charcoal in a circle, or we put it in lines? We got these more controlled drawing shapes. So that's from that. So that's the one on the left. There's 2 lines right off the page, and we just dropped the caterpillars and convinced them to walk across the page from either direction. So yeah, those are the drawings. And then the first one is the earlier work, which is the caterpillar life cycle. And that one I purposely messed with the chronology because I was getting away from moths and more to caterpillars, and so I wanted to highlight every stage and not privilege the adult stage, because most literature, like there's tons and tons and tons of stuff on butterflies and moths, super popular. Nobody cares about the caterpillar. No, that's not, lots of people care about caterpillars, but we tend to think in art and aesthetics about butterflies, but these ones are particularly uninteresting because they live for like a day and a half if they get there. They're ugly and they're brown and it's so gross they can't eat and they can't fly.
Did you know starting on this project that the older caterpillars wanted to just do their own thing?
No.
So this is all organic?
This is all, like, a lot of the stuff was discovered. We also didn't know that they would walk for hours under a hot studio light. We had no idea. We thought they'd get fed up and stop walking, or they'd get angry, or they'd go the other way. What's really weird is, so Chris's research was how long will caterpillars stay on preferential food, and what will they happen if they're on not very good food. And he found that when they're on not very good food, they would scatter. They look for better food, and they get very independent. Even though scattering makes them more vulnerable to predation, they don't have safety in numbers, they get lost. So what we realized is they actually they will stay together if there is no food, but they will scatter if there's bad food. So there's some things that and of course the cartography is also kind of something we came up with on the spot. So as far as we know, no scientist has tried this. So we were kind of curious, but science moves at a very slow pace. But I was also very interested in whether there was any scientific knowledge that was generated out of this. So the one thing was that we were able to use the caterpillars, and actually the caterpillars that did the drawing while we were in the exhibition weren't even our caterpillars. They were swarming caterpillars from McGill. We went to our rival university and stole them off the rose beds they were eating, and then brought them back to our school and did drawings with them. And then the thing is, we can't release caterpillars that are raised in a lab, but we went back. We took them back to McGill and dumped them back where they came from because, we weren't hurting anything, but you can't. We had to be very careful not to let these caterpillars go free because we didn't want to cause another outbreak in the city. So they had to be euthanized. We did let a bunch of them spin. So after the show went on for 6 weeks, the caterpillars were starting to go into we left a handful of them to spin into cocoons, and so we did leave one thing, and I think 8 of them got all the way to cocoons, and I think they came out as especially feeble moths. So you can raise them in a lab, but you can't. They don't reproduce well. Like there's never any success, so they have to. Unlike silkworms, which have been they're like cows, they can be raised generation after generation under artificial circumstances. These guys you have to get the eggs from the wild. They have to be in the wild to produce viable eggs. But we did let some get all the way because we just never let them free, and then they just died naturally. But most of them went into the freezer and then were preserved in alcohol and used in the study. So I don't know, maybe that's cruel. I'm not sure, but yeah.
Well, thank you very much. It's been so